Okay, to continue our discussion on annual compounding, let's consider the third example. Um, Take note that this is our formula for compound interest, specifically for the case where the interest rate is compounded once a year or annually. Okay. Okay. For our third example, let's consider this. A firm decides to increase output at a constant rate from its current level of 50,000 to 60,000 pesos over the next 5 years. Calculate the annual interest rate required to achieve this growth. Okay, this time we're asked to find for the rate of interest rather than for S. Okay, so what we will do here is simply to plug in the given, and then we'll be left with R, no, which is that given in the problem. So we're going to solve that. But to make it easier, I think it's easier if we solve for R first, okay? So that in our uh, if you will encounter the same problem, you can just use the formula for R. Okay. Okay. So since you are asked to find for R, then let's derive the formula for R from this formula. So what we're going to do is to isolate this R, no, on one side of the equation. That means that we should remove P and T here. Okay. It's easy to remove P because we can just divide both sides by P. So if we do that, then we'll have S over P equals 1 plus R raised to P. The next thing that we're going to remove is this exponent P. Now, removing T from the expression is not easy, but we can recall from our algebra that if you have two numbers which are equal, then their nth root is actually equal. And also, the nth root of x to the n is equal to x. Now, we're going to use this property to solve for R. In particular, to remove this t here. What we're going to do is to get the nth root or the t root of both sides so that this t will be removed using the second property. Okay, first using the first property, we express both sides as the t root of the left hand side and then the right hand side. Okay, and then notice the right hand side here. This is actually very similar to the form, no, of the second property. So that means when we apply this second property, we this t root, this radical form will be eliminated, and therefore you will obtain this expression, right? I hope you can follow. Okay, we applied the second property so that this t root of 1 plus r to the t is written in this form. Okay, so we arrived to an expression where we can easily isolate the r. And how do we do that? You can just subtract both sides by 1. So that means that r is equal to t root of s over p minus 1 equals r. So the formula for r is therefore given by t root of s over p minus 1. Okay, so let's solve this problem using now the formula. I indicated the formula here. Okay, again, having the formula, we need only to identify the given values from the problem. So your P is equal to 50,000. That's your initial amount actually, okay? And your S is equal to 60,000 because that's the amount we want to attain or achieve, okay, for the past 5 years. And your T is equal to 5, okay? So we plug that into this formula. Your formula is R equals fifth root of the square root of S over P minus 1. So we substitute the given. We have this expression, right? Okay. R equals fifth root of 60,000 over 50,000 minus 1. And then again, using our calculator, if you are using a scientific calculator, no, there's a way to compute for the fifth root, okay, of a certain expression. So look for that function in your calculator. And then subtract by 1, then you have 0.037137 dot dot dot. Or this is approximately equal to 0.0371, which means that the annual interest rate required, okay, to achieve this growth from 50,000 to 60,000 for the next 5 years is 3.71%. This is the needed or the required annual interest rate to achieve the growth from 50,000 to 60,000. Okay. Next example, okay, still under compounding annually. This time, we have the case where we are asked to find for the number of years, and the number of years is T, right? Okay. The principal amount is given, the rate of interest is given, and this is compounded annually. So how do you find for time? Okay, remember the formula, okay, for S, P times 1 plus R raised to T. This time, we're going to find for T. We again do some manipulation, no, of the formula. And since we're asked to find for time, we have to derive a formula from this formula for annual compounding. Okay, of course, first we isolate P. No, we divide both sides by P. That means that we have S over P equals 1 plus R raised to T. The problem here is how to isolate T because T is an exponent. Okay, we need help from properties of logarithms, in particular the natural logarithm. If you remember, we have a logarithm that's, we have a property that says if A is equal to B, then ln of A is equal to ln of B. Of course, this holds only when A and B are non-negative. I mean, greater than 0. Okay. And then the second property says that the ln or the ln of x to the r is r times ln of x. Okay, so you have two expressions which are equal. We use the first property. That means we express both sides in terms of ln or ln. We have this expression, right? Okay, ln of the left-hand side is equal to the ln of the right-hand side. Okay, and then after that, remember your objective is to isolate t. Now, unless t is converted as a non-exponent value, we cannot isolate that. So we need to convert that to a non-exponent value, or a non-exponent number, no? So how do we do that? We can use the second property, because in the second property, if you have ln of x to the r here becomes now a factor, no, together with ln of x. So see where r went to, right? Okay. So using that property, this expression can now be written as ln of s over p, which is equal to t. Okay, so your t will go here times ln of 1 plus r. So It's easy now to isolate t. We need only to divide both sides by ln of 1 plus r. And therefore, your t is equal to ln of s over p, is 1 here, divided by ln of 1 plus r. So therefore, the formula for t is given by this expression. Okay, and we're going to use this to solve this problem. And solve this. So we have the formula now for t. Okay. We first identify the given. Okay, what are the given values? We have P to be 25,000. Rate of interest is 12%. And your amount, no, the future value is 250,000. Okay. Let's plug that in to this formula. This will become T equals ln of S, which is 250,000, over P, which is 25,000, over ln of 1 plus R, which is 0.12. Then we can compute this easily using a scientific calculator, and it will give us 20.32 years, or approximately equal to 20 years, for 20.32 years. Okay, so that's how to determine the time when the rest of the quantities are given.